My beloved students, welcome to this session. In this session, we are going to solve a linear PDE whose coefficients are constant and homogeneous, and my right hand side is going to be y cos x or y sin x cos y or x sin y. Before going to the session, we need some preliminaries. We know what is the integration of x dx. It's simply x square by 2 plus c. We know the integration of cos x dx. Cos x integration is sin x plus c. But in this problem, we are going to integrate x into cos x or x into sin x. In this case, how to do the integration. In your school, you may study integration by part. When the power of x is getting increased like 2 or 4 or 6, it is tough to do integration by parts repeatedly. So we are going to use Bernoulli's formula. So the Bernoulli's formula is u dv. How to remember it is very easy. You just take uv, 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 uv everywhere. First one is plus, minus, etc. Now first term is uv, second term is u dash v1, u double dash v2, u triple dash v3, etc. This is your Bernoulli's formula. Now it is important that which I should choose as u and which I choose as v. Suppose you take the problem x square cos x dx. Now you see cos x is a non-diminishing function. Either you integrate or you differentiate. So cos will become sin, sin will become cos with positive negative, but it will not diminish. But when I take x square differentiation is 2x. Then 2x differentiation is 2. Then differentiation of 2 will become 0. So x square when I differentiate thrice, I'll make it as 0. It is diminishing. So now my choice u, I should take the function which is going to diminish. With this idea, now we are going to crack this problem. How to integrate x square cos x dx. Now I'm going to take u is equal to x square and dv is equal to cos x dx. Now u dash is 2x, u double dash is 2, u triple dash is 0. Similarly, integration of cos x is sin x and integration of sin x is minus cos x and integration of minus cos x is minus sin x. Now I'm going to apply this in the formula. uv, u dash v1, u double dash v. From u triple dash, all are going to be 0. So it is easy for me to finish the problem. Now you see integral x square cos x dx is simply uv, that is x square sin x minus 2x minus cos x plus 2 minus sin x. I close the problem. So what is the hint here? If you have x square in the problem, the answer has 3 terms. If you have x, the answer has 2 terms. If you have x cube, the answer has 4 terms. Hope you understand. So this basic formula is needed to solve this type 5, as well as it is very important for your unit 2, 3 and 4. So with this idea, let us go into the problem. So these are all the problems we are going to deal in this video. Let us go into the problem. Now as usual, we take LHS, that is going to be my complementary function. Put d equal to m, d dash equal to 1. You get the equation. So we are going to split this into 2. m minus 2, m minus 3 equal to 0. So my m value is 2, 1, 3 and my CF. Next we are going for PI. When you want to solve the problem with right hand side, y sin x or y cos x, etc., you take the PI. The denominator you should write like this. How I arrive this? Let us take d square minus 5 dd dash plus 6 d dash square. From the auxiliary equation, we know this m minus 2 into m minus 3 equal to 0. We get m equal to 2. Now, using this auxiliary equation, I am going to rewrite this like this. So I am going to put m is equal to d, the reverse part. Like this you can easily remember m equal to d and 2 into 1 I consider. So it is d dash. Similarly, m equal to d, 3 d dash. So instead of this, I am going to replace this. So my PI is going to be 1 divided by d minus 2 d dash, d minus 3 d dash y sin x. Now we have a formula to crack this problem. So if I consider 1 by d minus m d dash f of x comma y, initially we know my f of d dash z is equal to some function of x comma y. So this is equivalent to integral capital F of x at c minus mx dx, where c minus mx is equal to y. I am going to replace this y by c minus mx because my denominator is like. Suppose your denominator is d plus m d dash. I am going to replace y by c plus mx and then I integrate. While you integrate, you can use Bernoulli's formula. That is the idea behind this problem. Now I am going to keep this d minus 2d dash and I am going to use this. According to our formula, it is going to be integral c minus 3x, because here I am using d minus 3d dash. I am going to take this y as c minus 3x sin x dx. So now to integrate c minus 3x sin x dx, we need Bernoulli's formula. I'll take u as c minus 3x, u dash is going to be minus 3x, u dash is going to be minus 3, u double dash is going to be 0. dv sin x dx, v minus cos x dx, v1 minus sin x dx. So the solution is going to be uv u dash v1, remaining all terms get 0. Since the power of x is 1, we get 2 terms. So the answer is c minus 3x minus cos x minus minus 3 into minus sin x, because the Bernoulli formula is integral u dv uv minus u dash v1 plus u double dash v2 etc. Here only 2 terms exist. The first term uv u dash v1. Hope you understand. Now let us substitute in this problem. So when we integrate, we get this. When we simplify this, we get minus y cos x minus 3 sin x. Since the integration is over, now c minus 3x should be replaced by y. That's what I did here. So now first half of the problem is over. Again, I have one more part in the denominator. So for this part, I am going to take this y as c minus 2x, because I have d minus 2d dash. So y I am going to replace by c minus 2x cos x minus 3 sin x dx. And now you see, I'll take this minus outside, c minus 2x cos x dx minus 3 sin x dx. So this part I can easily integrate. Sin x integration is minus cos x, minus into minus plus. So I have 3 cos x. Now this part I have to integrate with Bernoulli's formula. I am going to take u as c minus 2x, then u dash is going to be minus 2, u double dash is going to be 0. dv I am going to take it as cos x dx, v is going to be plus sin x and v1 is minus cos x. Now club the problems using Bernoulli's formula. Integral u dv is equal to uv minus u dash v1 plus u double dash v2. So since we have only 2 terms, the answer is going to be c minus 2x sin x minus minus 2 into minus cos x. So when we simplify this, I have to replace c minus 2x by y. So I get minus y cos x. So minus into minus plus, but there is one minus here and one minus outside. So it is going to be plus 2 cos x. And this term we have already integrated separately, plus 3 cos x. So my answer is minus y sin x plus 5 cos x. So my pi is 5 cos x minus y sin x. Now it's time to write the solution. Z equal to Cf plus pi. That is going to be f1 of y plus 2x, f2 of y plus 3x plus 5 cos x minus y sin x. Hope you understand how to solve this problem. Now there is a similar problem which is also equivalent to sin x. It is y cos x. So these two problems are some important repeated problems in the previous university questions. So I have took this. So let us find the complementary function. M is equal to 2n minus 3. So my CF is going to be y plus 2x, y minus 3x. Now I want to find pi. So I can rewrite this as m minus 2 m plus 3 equal to 0. So I can convert this d square plus dd dash minus 6d dash square as d minus 2d dash d plus 3d dash. Next, in the similar way, we are going to solve the problem on y cos x. Now let us find the CF. The auxiliary equation is m square plus m minus 6 equal to 0. When I put d equal to m, d dash equal to 1. My roots are 2, 1 minus 3. So that is m minus 2, m plus 3 equal to 0. So I can write the CF. When I want to go for pi, using that m minus 2, m plus 3, I can write my denominator of my pi as d minus 2d dash and d plus 3d dash y cos x. Now as usual, we have to solve the problem by using Bernoulli integration. So here in this problem, u is equal to c plus 3x, u dash is 3, double dash is 0. dv is cos x dx. So integration of dv is sin x and v1 is minus cos x. We know the Bernoulli formula, integral u dv, uv minus u dash v1 plus u double dash v2 etc. So now we map this. So my answer is going to be c plus 3x sin x and minus 3 into minus cos x. Two terms exists because the power of x is 1. And after integrating, replace c plus 3x by y. Now we have d minus 2d dash. When I replace the c plus 3x by y, we get y sin x, and minus into minus plus, so we get 3 cos x. Now again we have to integrate this according to the formula. I'm going to take y as c minus 2x sin x dx plus integral 3 cos x dx. So this is going to be obvious, 3 sin x. For this I have to integrate. My u is c minus 2x, u dash minus 2, double dash 0, dv is sin x dx, v is minus cos x, v1 is minus sin x. It is going to be c minus 2x into sin x plus 3. So the integration of c minus 2x sin x is c minus 2x minus cos x minus 2 into minus sin x. Now replace c minus 2x by y. So we have minus y cos x minus into minus 2 sin x plus 3 sin x. When we simplify, we get minus y cos x plus sin x. So this is the general solution, CF plus PI. Thank you for watching. Subscribe our channel, share to your friends. Meet you in the next video. See you.